Dear student, today we are going to study the practical of superposition theorem, and we will see first of all the theory of the superposition theorem, and after that we will perform the practical. Okay, so this is one of the circuit here. The two voltages are given, one 8 volt and one 4 volt. There are the three resistors where the values are given 120, 120, and this is 1K. Now the first condition is that we have to short the V2 and keep the V1. Now after shorting this V2, we will find the equivalent resistance. These two resistors are in parallel, so we will get the one equivalent resistance. And after getting the answer of this resistance, we will add these two resistors. So the equivalent resistance is becoming 2p7. Okay. So now we have to find out the I1 dash first. I1 dash is the equal to V1 upon RT. V1 is the value of 8 and this is the resistance value. In this way, we will get the I1 dash. Now we have to find out the I3 dash. I3 dash is what? I3 is equal to I1 dash into 120 upon 1000 plus 120. Okay. Now at last we have to find out we have got I1 dash, I3 dash. Now we have to find the I2. Now how we can get this I2? So this is the we are applying KCL. KCL now incoming current toward the nodes is I1, outgoing is I2 and I3. So our equation becomes I1 dash is equal to I2 dash plus I3 dash. So I2 dash is equal to I1 dash minus I3 dash. We will get, putting these two values, we will get the I2 dash. In this way, first case finished. Now second case. Now this is the second case when we will keep the voltage V2 and we will short the V1. Now the current direction get changes here. Okay. Now these two resistors are in parallel, so we will get the equivalent resistance this, and these two resistors are in series, so we will get the RT equal to this value. Now we have to find out the I2. I2 is this. I2 is equal to V2 upon I2. So we will get this I2 double dash. I3 double dash means I3 double dash is equal to total current. This is I2 double dash into opposite resistance 120 upon sum of resistance. We will get this I3. Now double dash I2 double dash is equal to I1 dash double dash plus I3 double dash. So now we have the value of I2, I3, but we don't have the value of I1 double dash. So I1 double dash is equal to I2 double dash minus I3. In this way we will get I1, I3 and I2. Okay. Now, at last, we have to find out the I3, I1, I2. Now, I3 is equal to I3 1 dash. This is here, the value, plus I3 double dash. This is the value of this. Okay, in this way, I1 is equal to I1 dash minus I1 double dash. And I2 is equal to I2 single dash minus I2 double dash. In this way, we will get the three currents, right? Okay. So, now we will perform the superposition theorem practically. This is the dual power supply and these are the currents. This is for I1, this is for I2, this is for I3. We have connected to this circuit. These are the three resistors here. We have given the power supply. Okay. Now we will match the theory I1 dash, I2 dash to I3 dash. Okay. By short circuiting the V2, we will short the V2 and we will apply the V1 on the power supply. Now we will give the 8 voltage here. Theoretical also we have given the 8 voltage. Now we will check the what is the value of I1. I1 here is 35. Here practical is also 35. Right? Clear? Now for I3 we have got the 3.7. So this is the I3. We have got 3.7. Right? Now for I2 we have got 35 for practical, same as that is the for here. Now, this is first case. Now we will move toward the second case. Okay. We will move toward the second case, that is keeping the V2 voltage source and shorting the V1. Okay. Now we will on the power supply and give the 4 volt DC. See now the current for I1, that is here we have got the 15 milliampere. Here also same we have got the 15 milliampere for I1. Right? Now, for second, that is the I2. Theoretical, we have got the answer 17.6 milliampere. Here also, practical also near about 17 milliampere. Now, for I3, theoretical value, we have got the 1.8 milliampere near about. Here, the same for the practical value for I3. Right? In this way, we have performed the superposition theorem. Okay, thank you.